Welcome to the Unit 6, Section 5 video on solving by elimination. So we did substitution in the last section, and now we have another method called elimination. Just like in substitution, the goal here is to get one equation that has one variable. And if we can solve for one of those variables, we can plug it back in and get the other one. So let's recall one of the earlier lessons that we had on equations, and that is equations have to stay in balance. So what that means is whatever you do to one side of the equation, you have to do to the other side, or otherwise you lose that equality, you lose that balance. Well, consider the system x minus 2y equals negative 19 and 5x plus 2y equals 1. Since 5x plus 2y equals 1, you can add 5x plus 2y to one side, and then you can add 1 to the other side of the first equation. And we still maintain our balance because those quantities are equal to each other. So if we add 5x plus 2y to one side of the equation, we're left with 6x, which you see on the left-hand side of the scale. If we add the 1 to the other side, we're left with negative 18 on the other side of this scale. And these two values remain balanced, which means 6x will equal negative 18. What we've ended up doing as a result is eliminating the two y's, the negative 2y and the positive 2y. Since they had opposite coefficients, you add them together and they are eliminated, hence the term elimination. When you use the elimination method to solve a system of linear equations, you want to align all the like terms in the equations, and then you want to determine whether any like terms can be eliminated because they have opposite coefficients. So you will write the system so that like terms are aligned, eliminate one of the variables and solve for the other variable, substitute the value of the variable into one of the original equations and solve for the other variable, and then write your two answers as an ordered pair. So let's take a look at how this works, starting with this example 1. So the first thing you're going to do is you're going to write the equations in column form. So we take the first equation and we stack it on top of the second equation. We line up our x terms, our y terms, and our constants on the right-hand side of the equals. To get the two y's to cancel, one is negative, the other is positive, so if you add them, then they will cancel. So what we're left with is x plus 5x, which is 6x. Our y terms eliminate, and then negative 19 plus 1 gives us negative 18. So notice here that the y is eliminated when we do this. And then all that's left to do is divide each side by 6, which gives us x equals negative 3. Now we're going to substitute negative 3 in for x in either equation to find the value of y. So let's do that in the first equation. We plug negative 3 in place of x, add 3 to each side, so negative 19 plus 3 gives us negative 16. And then divide each side by negative 2, which gives us y equals 8. So our solution is negative 3, 8, since our x term is negative 3, and our y is 8. Now when two equations each contain the same term, you can subtract one equation from the other to solve the system. To subtract an equation, you will be adding the opposite of each term. So let's stack these two equations in example 2, just like we did before. And to get the 4y's to cancel or to eliminate, we will subtract them because 4y minus 4y gives us 0. Now, to make the math a little bit easier, I'm going to take the second line and I'm going to flip the sign of everything. So negative 2x becomes positive 2x, positive 4y becomes negative 4y, and positive 8 becomes negative 8. And then I'm going to switch my operation to addition, and now we have a problem like we did in example 1. 3x plus 2x gives us 5x, 18 plus negative 8 gives us 10, and our 4 y's cancel. Divide each side by 5, and you get x equals 2. Now we're going to substitute 2 in for x in either equation to find the value of y. Let's do it in the second one this time. negative 2x plus 4y equals 8. X equals 2, so we're going to plug that in. Negative 2 times 2 is negative 4. Add 4 to each side. 8 plus 4 gives us 12. Divide each side by 4. 12 divided by 4 is 3. So we have x equals 2, y equals 3. So our final solution is 2, 3. Now, in some cases, you will first need to multiply one or both of the equations by a number so that the variable has opposite coefficients. So what we're going to do is take two equations that don't work with elimination the way that they're set up, and we are going to make them work for elimination. So here, I've gone ahead and stacked our equations like we always do, and we're going to go ahead and add. But what I'm going to do is take the second equation and multiply it by 2. So our first equation remains the same on the top. I'm going to multiply the second equation by 2. So negative x times 2 gives us negative 2x. 3y times 2 gives us 6y. And negative 12 times 2 is negative 24. Notice now we have the same coefficient for x. We have positive 2 and negative 2, which when added together is going to give us 0. So the x term will eliminate. Y plus 6y gives us 7y, and 3 plus negative 24 gives us negative 21. Divide each side by 7, and you get y equals negative 3. Now we will substitute negative 3 for y in either equation and find the value of x. So let's take the first equation. Substitute in negative 3 for y. Then add 3 to each side, which gives us 6 on the right-hand side. And then divide by 2, which gives us x equals 3. So our final answer is 3, negative 3, since our x term is 3 and our y term is negative 3. In example 4, we are going to use elimination here as well, but we have to multiply both equations. So if we multiply the top equation by 2, our y term will become 24. If we multiply the bottom equation by negative 3, then the bottom equation will become, the bottom y term will become 24. So multiply the top equation by 2. 7x times 2 is 14x. Negative 12y times 2 is negative 24y. Negative 22 times 2 is negative 44. On the bottom equation, multiply it by negative 3. 5x times negative 3 is negative 15x. Negative 8y times negative 3 gives us positive 24y. And negative 14 times negative 3 gives us positive 42. Now we can eliminate the y by adding these two equations. 14x plus negative 15x gives us negative x. Negative 44 plus 42 gives us negative 2. Divide each side by negative 1, and you get x equals 2. Now we're going to put 2 in place of x in our first equation. So 7 times 2 gives us 14. Subtract the 14 from each side. You get negative 22 minus 14, which is negative 36. And divide each side by negative 12, and you get y equals 3. So our solution here is 2, 3. X is 2, y is 3. So that finishes off this section on elimination. Coming up in the final section of the unit, we are going to take all of these tools that you have now accumulated, solving by graphing, solving using technology, solving by substitution, solving by elimination, and we are going to put these into practice by doing real-world applications.